Okay, so in problem number 25, we have this integral, and one thing that I notice about this integral right away is we have the sum of two terms in the numerator. So one thing that we might do is break this up into two separate integrals by breaking apart that fraction. So I know we've done this many times when the denominator is just one term, but we can actually keep the denominator x squared plus 1 and still break this up into two separate integrals, even though we have two terms in the denominator. Okay, so now let's look at these two separately. The first integral, you might notice, hopefully you notice, that we almost have the derivative of the denominator in our numerator. So we just need a fudge factor of 2 and a 1/2 out front, and then this fits the rule that says the integral of the du over u is equal to the natural log of u plus c. And then we have, so that first integral is 1/2 the natural log of, don't really need absolute value bars this time because x squared plus 1 will always be positive for any real number x. So absolute value bars would be extraneous. So the second integral here, the integral of 4 over x squared plus 1 dx, well, the 4 is kind of in the way, but if we factor out the 4, maybe it'll look a little more familiar to you. So factoring out the 4, we end up with an integral of 1 over x squared plus 1, and that fits our inverse tangent formula. So we wind up with here 1/2 natural log x squared plus 1 plus 4 times the inverse tangent of x. It's x over 1, which is x, plus c, of course.